Hi, I'm Gary Watson. I'm the Chief Technology Officer and co-founder of Nexsan, and I'd like to talk to you today about our technology and how it can be used to simplify your data center processes. But first, let me give you a little history of Nexsan, just really quick. Some of the things that are interesting about us: we were the first to do many things. We were founded in April of 1999, and in 1999, our very first innovation was the idea of using a web-based interface for a mid-range storage array. Web-based interfaces had never been used in a storage array before. That was in 1999. In what we're probably most famous for, in 2001, we introduced the concept of enterprise ATA. That is to say, using ATA drives for enterprise storage applications, hot pluggable, redundant controllers, that sort of thing. And it was very disruptive at the time because it was about 10 times cheaper per gigabyte than the competitive systems on the market in those days. And it enabled a whole family of new applications, and especially when we introduced our fiber channel attached version in 2002. In 2002, fiber channel was an exotic technology even for enterprise storage arrays, and to have it connected to a very low cost ATA array was pretty amazing. In 2003, we introduced our high-density storage packaging with 42 drives in a 4U package. So we already had a 6 times density advantage, times 3 or 4 times the density in terms of drive slots compared to other people. So 42 drives, and that was what we called the ATA Beast. There are still ATA Beast in production today, 10 years later. We refined it into the SATA Beast, where we've sold approximately 10,000 of these over the years. And then most recently, we introduced a few years ago the idea of active drawers, where you had drives that fit in drawers, and the drawers could slide out, and you could add or change drives non-disruptively in the system, giving you, in this case, up to 60 drives in one system. And then earlier this year, Nexsan was acquired by iMation Corporation. iMation's out of Oakdale, Minnesota. It's a billion-dollar company. And we've effectively become the enterprise storage division of iMation, and we're integrating rapidly into the iMation sort of family, and it's been great for everybody. We've sold to, I know everybody has logo slides, but we've sold to lots of interesting customers, and because we pioneered the concept of high-density, low-cost storage, we were the pioneers in enabling many applications that didn't even exist before. For example, CCTV, that's digital video security. These people often deploy petabytes of storage and in all kinds of environments: casinos, power plants, train stations, even on cruise ships, where they roll out petabytes of storage for these applications. Nexsan's one of the biggest vendors in that space. Some scientific research sites that have over 10 petabytes apiece of Nexsan storage on the floor. And we're very big in medical and manufacturing and all kinds of interesting applications. But tell you a little bit more about the technology of the block storage products that we have today. We call them the E-Series. The E-Series is our active drawer-based technology. We have 3 basic models. We have an E18, an E48, and an E60. An E18 has 18 3.5-inch drives in a 2U package. So most competitive products have 14 to 16 drives in 3U. We fit 18 in 2U, including 2 RAID controllers and 2 power supplies. And it's very, very easy to manage these. It doesn't require a great deal of technical skill to do it. And we've been very successful selling these on the market. And they have all the usual features you would expect: active RAID controllers, various host options like 10 gigabit iSCSI, 8 gigabit fiber channel, and so forth. And some interesting technologies like AutoMade, which allow you to save a huge amount of power in installations. So using the E60, for example, with an E60 and 2 E60X expansion units, you can have up to 720 terabytes in 12U of rack space. That's so much. That's just an amazing amount of storage, very economical, very high density. Well, we think hardware matters. We realize that there's a lot of people who are racing to the bottom with commodity white box storage making up enterprise storage solutions. We do think hardware matters. This is the E60 package with the active drawer technology. I'll just give you a couple of examples of things we've done. Vibration's the enemy of reliability in a high-density product. So, for example, you may be able to tell here, we mount the drives in back-to-back counter-rotating couplets. So if you imagine if you had 60 drives all spinning at exactly the same speed like this, it's a huge amount of energy to the fans. And in a normal computer room environment with normal activity, with no failures, the fans will typically be running about half speed. So fans that run half speed last about 10 times longer and make a very much less amount of vibration. And they use a lot less power as well. So there's a lot of advantages to that. And it's just a very high quality system. If you do get a chance to get your hands on one, you'll see that it's built more ruggedly and more professionally than most of the products on the market today. We also have a product family called Assurion. Assurion is our high integrity file archiver. It's intended to be a repository for files that just can't be deleted or changed. So that typically breaks down to healthcare applications like PACS imaging systems. We're certified on most of the major ones. A lot of financial SEC 17A-4 type applications where you have to provably store your files in such a way they're tamper resistant and can't be changed. And digital media and federal and state applications, many different types of applications for this product family. I'm not going to go into it in any detail today, but just let you know that we have this. But the main thing I want to talk to you about today is our NST family. The Nexsan NST 5000 and NST 6000 family are our unified hybrid dense storage products. So unified means they have unified block and file protocols. So CIFS and NFS, CIFS for your Windows people, NFS for Unix, iSCSI, and now Fiber Channel. So 4 protocols from one set of hardware. Unified in the sense that it's one GUI that manages all the protocols, all the storage, all the arrays on the back end. It's all done from one pane of glass. In fact, that pane of glass can manage all of your NST systems worldwide if you want it to. Hybrid means it's a combination of spinning media and solid state. In our case, we use 2 different tiers of solid state, where we have a RAM-based tier and a flash memory-based tier, and that's why we call it fast tier. That's our caching technology. And then on storage, you can have 15K drives, 10K drives, as well as 7200 RPM capacity optimized drives, up to a maximum of 5 petabytes today. So in terms of the operating system, it supports a lot of the enterprise type features that you're accustomed to and the best systems that are on the market. Online capacity expansion, it's all a big virtualized pool, so you can add storage whenever you want to. The pool just grows. From this common pool of storage, you carve out iSCSI LUNs, Fiber Channel LUNs, CIFS and NFS file shares, and they all share the storage, which is inherently thin provisioned. You don't have to thin provision it if you don't want to, but most people do because it's easier to deal with. It's essentially no performance impact, and it's reservationless and very generous in terms of how many snapshots you can have. 2,000 per, over 2,000 per share or per LUN. And we have built-in asynchronous replication that allows you to replicate over any distance. And the asynchronous replication is based on the snapshot technology. We take the snapshots, we take the delta blocks, we deduplicate them, and we compress them, and we send them across the WAN. So it's very, very WAN efficient. We also have a synchronous replication technology, which is called metro clustering, where you can have 2 different nodes separated by distance up to 10 kilometers and have lockstep synchronization between the 2 sites. On the NAS side, simultaneous CIFS and NFS, you can have a single share be visible on CIFS and NFS simultaneously. We support all the usual security protocols like Active Directory and LDAP. And if you don't have either one, say it's an embedded application, we have built-in security as well. You can use any or all of those. We support quotas with oversubscription. We have a end-to-end CRC protection model where the data and the metadata is protected with CRC integrity checks from end to end. So if a data gets corrupted somehow, we will check that on reads, but we also have a background process where we scrub through the files and make sure that they're all readable and have correct bit pattern integrity. We support NDMP, of course, and we have on the iSCSI and Fiber Channel side, we support up to 64 terabyte LUNs, which is very, very large. And by the way, that's actual tested QA'd capacity. All the numbers I'm talking about today are things we've actually built and tested. That's not necessarily a theoretical limit, but very few operating systems can even handle that size of a share, of a LUN. And we have, of course, because of our history of block storage products, we have a very powerful LUN masking technology. And it's thin provision, just like the NAS side is as well. If you're running Windows, we support Microsoft VSS completely, so you can have application consistent snapshots. So the basic models of the NST 5000, which has been on the market a couple of years, is the NST 5100, NST 5300, and NST 5500. The 5100 can go up to 93 terabytes. The 5500 can go up to 5 petabytes, and in the middle, we have the NST 5300, which can go up to 720 terabytes. So the most popular model is the 5300, but we have quite a number of each of the larger and smaller models out there as well. 5 petabytes is quite a lot of storage. We have also a wonderful user interface. It's a three-dimensional wheel technology, which allows you to easily scroll through your system. It kind of feels a little bit like an iPad, scrolling through. You're exploring your environment. And if you don't want to use the GUI, let's say like you're rolling out 1,000 identical shares, there's also a full-featured CLI if you want to script it, and they're not mutually exclusive. You can do both. And it's role-based too. You can have an administrator just for one pool of storage. You can have an administrator for the site, or you can have a worldwide administrator who can see all of the sites and manage them. And then we have a number of wizards to guide you through the most common tasks that you might want to do. So let's talk a little bit about SSD technology for a minute, because I think this little digression, you may find this interesting. We've been playing with SSDs for quite a long time, and SSDs are nothing new. In fact, I designed one 25 years ago, so they've been around a very long time. But let's talk about some interesting things. So first of all, a spinning disk actually has very good read-write bandwidth for sequential workloads. So you actually have to pay quite a lot of money for an SSD that can sustain the write speed of an ordinary hard drive. Only the best SSDs can do that. It's also symmetrical. A spinning disk has the same read and write performance, whereas a flash-based device typically reads much faster than it writes. And the less expensive or less sophisticated the SSD is, the bigger the gap between the write and the read performance. But of course, spinning disks can only do a small number of IOPS, 100 to 300 IOPS per drive, whereas a SSD can be tens of thousands of IOPS per drive. But the cost per gigabyte is very much different, probably 5 to 10 times difference in cost, depending on what you compare exactly. And but then there's one thing that we have to pay very special attention to, and that's called write durability. So it turns out that a spinning hard drive, actually, it's good for it to write to it. It makes it more reliable. Whereas a flash-based device has an inherently limited write cycle durability. So there's a certain amount of reading you can do to it during its lifetime, and then it stops working because it wears out. And there's also a weird phenomenon where some flash-based SSDs, they have odd performance on writes. So this graph, you won't be able to see the details on the screen, but I'll explain it to you what you're looking at. This was a test done by the Storage Networking Industry Association about a year ago. They took 8 good quality name brand SSDs, and they did a very simple test. They simply set them all up and started writing to them. And they measured the write performance versus time. Now, on a hard drive, that would be a flat line. It's the same write performance all the time. But what happens on these devices, the different colors or different specific drives, that they start out and they go a certain speed, and then the speed plummets in some cases up to 99% after a short period of time. And some of them don't do that. They go down maybe 20, 30, 40%, and then they stay nice and stable. Others exhibit this weird performance, or this red one, where the performance continues to decline. So let me explain to you what's happening. A flash device, when you buy it, the term is fresh out of box. All of the flash inside is blank. So what happens is, as soon as you've written one capacity's worth of data to that flash drive, it now has to start recycling blocks. The recycling process is what takes a huge amount of time. and resources, and the certain technologies like MLC flash technology and the consumer grade controller technologies, that is actually a very inefficient process that takes a huge amount of time. And so those devices are not optimized for writes, they're mostly optimized for reads. So then there's this red one where the performance goes down and then continues to decline. What's happening there is another buzzword called throttling. So the drive has detected in its firmware that at the rate you're writing to the drive, you're going to wear the drive out before its warranty period, and it's deliberately getting slower and slower as a precaution to prevent you from wearing out that device. Now that's fine if it's in a laptop, but that's not good behavior if you had that designed into some kind of enterprise storage product, because that's not the behavior you want an enterprise storage product to behave. It's just it's difficult and hard to predict. So what you'll find is the single level cell, SLC, sometimes called enterprise flash, has the behavior that the performance goes down a bit and then stays nice and stable, whereas MLC technologies are the ones where the performance plummets, up to 99% and stays low for the duration of the test. And so therefore, you have to be very careful about where you would use MLC technologies. And I'm getting to the point of why this matters. So first of all, not all SSDs are flash-based. So there are RAM-based SSDs. They're expensive, they're very fast, and they're very low capacity. And there are situations where those are valuable. We use them in the NST, and I'll talk about why in a minute. Then there are enterprise SLC flash devices, which can support up to a couple of 100,000 erase cycles per drive for its lifetime. And that means basically you take the capacity of the drive times 200,000, and that tells you the lifetime writes that you can do to the device. Now, if you do the math, 200,000 erase cycles times the capacity of the drive usually would work out to 5 to 10 years of heavy use before it wears out, which is plenty good enough. Then there's a new technology called enterprise MLC. Enterprise multi-level self-flash, the best of the newest generation of enterprise MLC, can do 100,000 erase cycles, which is enough for a heavy write-intensive application for the normal IT requirement of 5 years or so. Then there are MLC flash devices, which are only a few thousand cycles. These, if you do a heavy write cycle, they'll burn up in a month or so. Or maybe it's just a small number of months. And they're okay for laptops, they're okay for your iPhone, and they're okay for enterprise applications that are essentially read-only, like reference data, but they're not suitable for caching applications. So how we use this in our NST family is we use RAM-based SSDs for the most dynamically changing data. We use SLC or eMLC flash devices for read cache. And then we use MLC for nothing. We have no application where MLC or 3-bit per cell MLC. We've never found anything that it's good enough for in any of the products Nexsan sells. So now this could change in the future, but where we are today, the MLCs are just not up to where they need to be. So why are we doing all of this? There's a interesting phenomenon. A lot of people are starting to virtualize their storage. So and virtualizing storage has an interesting property. If you have a single physical server and you run a virtual machine on it, one virtual machine, the I/O that comes down the wire to us storage vendors looks exactly like that one virtual machine behavior. So if it's an OLTP application, what I see coming down the wire to my box is OLTP. If it's a email application, I see an email kind of workload. If it's a file sharing type NFS mount or something, that's what I'll see. But what happens when you put multiple virtual machines, no matter what they are, on a single physical server? It grinds up that data and interleaves it. So the traffic that you see down at the storage system is heavily fragmented small blocks of reads and writes. And so therefore, no matter what you think your application is doing, as soon as you put a bunch of VMs on a physical server, you're pretty much needing to optimize your storage for high IOPS, for high random IOPS. So one of the ways we get to high random IOPS is by using a lot of cache. So in the NST 5000, and I'll talk about the 6000 in a minute, what we do is we have cache, but we have two tiers of cache. And we need the cache to be fault tolerant against software failures, power failures, and so forth. So what we do is when the write data comes into one controller, it's stored in its write journal in RAM. A copy is sent to an external dual-ported RAM-based SSD. And then it's coalesced into a big, conveniently large transaction, and then it's written sequentially to the storage on the back end, which makes it very efficient from one end to the other. On the read side, the read data comes in, and if the algorithm thinks it's worthy of it, it stores a copy in the flash-based SSDs for high referencing performance in the future. So the reason it's designed for fault tolerance is if this controller fails, the surviving controller has a dual-ported access to the first controller's write journal and will commit the data to disk. If power fails, both of these write journals have a battery inside of them, and they will then dump their data to flash, and then when it powers back up, it will then commit it to disk. So it's designed to be redundant, power fail protected, software or hardware failure protected, and just generally redundant. It also has the benefit of using RAM, which is the fastest type of solid-state storage, for the most dynamic, fragmented, frequently changing data, such as write traffic. Now, we have a new generation product called the NST 6000 I'll talk to you about in a minute. It's very similar, but instead of using the external dual-ported SSDs, it actually has a very high performance interconnect between the two controllers, which allows it to mirror the write data to the partner controller. And then we have some fault tolerance technology to dump that to flash in the event of a power failure. So the NST 6000 is our new generation, our very high performance storage solution where you can have up to 4.4 terabytes of SSD. You can have up to 384 gigabytes of RAM per controller. So it's a very large amount of RAM that's available. We have up to 64 gigabytes of non-volatile write cache per controller. And there's two controllers on these systems. In order to synchronize the cache between them, we've developed a PCI Express non-transparent bridging technology, which effectively is about a 16 gigabyte per second, extremely low latency interconnect between the two. So the latency is even less than using InfiniBand. So it's a very, very high performance, low latency technology for mirroring the data between the two. And we're supporting up to 5 petabytes at launch. Launch is basically right now. And we have a 10 petabyte QA process underway where we will be announcing at some point a 10 petabyte solution. And I may be getting old, but I remember when a petabyte was a lot of data. We're now selling petabytes the way we used to sell terabytes. So it's much more inexpensive to do petabytes these days. You can fit nearly 3 petabytes in a rack today using Nexsan products. So from the unified storage pool, you can carve out Fiber Channel at 8 gigabit, iSCSI at 1 gigabit or 10 gigabit, CIFS and NFS from 1 gigabit or 10 gigabit from this unified pool of storage. We've also added inline data compression. So if you have a workload where the data is compressible, this can save you a lot of power and time and money and wear on the disks and wear on the flash and makes the flash more efficient. It has all kinds of neat effects. And the new generation has a new generation processor and so forth that can do up to 700,000 cache hit reads from the cache, so per second. So that's quite a lot of performance. It can sustain over 5 gigabytes a second in throughput, and we have a configuration of this that can do metro clustering. So that was actually the first configuration we shipped. We're shipping them to a number of airports around the United States that are using them to have redundant data bunkers for security data. Now, the 6000 does not replace the 5000. The 6000 sort of sits as a family above the 5000. And it looks kind of like, well, here's the metro cluster first. I'll talk about that. This is the 6000 metro cluster where you have 2 sites. Data is synchronously replicated between the 2 sites. You have a redundant fiber channel connection between the 2 and a redundant IP network between the 2. So the users at site B can see their data through either controller, and both controllers can see all of the storage. In the event of a smoking crater, the other site continues immediately with no failover time. In the event of a failure of a storage device, both sites continue to operate normally. Now, there's not very many people who can do real metro clustering like we can, and it's a very powerful technique. It's very interesting, especially for Xen, Hyper-V, and when we get it certified, VMware people as well. So the basic family, the 5000 and the 6000 family, looks like this. We have the NST 5130, which is NAS and iSCSI 5330 and 5530. So that's NAS and iSCSI. 6530 adds fiber channel. And then there's the 6000 metro cluster, which has NAS, iSCSI, and will have fiber channel in the near future. So where we sort of position these is the 5130 is the entry unified NAS and iSCSI solution. The 5330 is a scalable, very flexible product. You can scale from, let's say, a few tens of terabytes to 720 terabytes of data. Quite a big range it can support. And there's a number of options within the 5330 as to how much SSD. You don't have to have any SSD if you don't want to, but there's quite a range of options as to how much solid-state disk acceleration that you want to use. 5530 is the big model of that first generation. We have a site that has 8 petabytes of 5500 on it that's running effectively a television network is being run off of it. The 6530 is the new generation, highly scalable, fully unified NAS, iSCSI, fiber channel. It's the highest performance product we have on the market today. And you might think of that in a couple of 100 terabyte region up to petabytes of storage. And then the NST 6000 Metro Cluster, the amount of storage, it could be anything pretty much, but this is for the applications where you really need that synchronous replication between sites. So with that, thank you very, very much. And I really appreciate your time listening to us. We have quite a number of things that we think are exciting. And